In this lesson, we are going to talk about arithmetic series. Now, if you recall, the arithmetic sequence was a series of numbers with the property that every term in the sequence is the sum of the previous term with a constant which we called d. For instance, if the first term was 2 and the constant was 5, then we would say the next term is 2 plus 5, which is 7. The next one is 7 plus 5 is 12. The next one is 17, and so forth. Now, an arithmetic series is the sum of an arithmetic sequence. So, we define the arithmetic series for this sequence is 2 plus 7 plus 12 plus 17 plus the last term, whatever the last term is. Now we are going to find the formula to find the sum of all the terms, n terms of an arithmetic sequence, which we call the arithmetic series. So the first example is to find the general formula for an arithmetic series. If there are n terms, the common difference is d and the first term is a. So the sequence becomes a plus d, a plus 2d, a plus 3d, and so forth until Tn. So what I have to do, I have to find the sum of these n terms. Let's denote that sum to be Sn, which is a plus d. This is the second term, plus the third term is a plus 2d plus, and the last term, which is t sub n. Now let's rewrite this sum as the following. Let's say Sn is, I'm going to write the sum from the last term to the first term. So t sub n plus t sub n minus d. Remember, the previous term here is t sub n minus d, because to get to the next term, I'm going to add d to it, so I get tn. And the next term is tn minus 2d, and this continues until the first term, which is a. Now let's add these two sums together. Sn plus Sn gives us 2Sn is equal to a plus Tn is the sum of these two terms. Then I'm going to add these two terms together. When I add them together, d and negative d, they cancel out, so I'm going to get again a plus Tn plus. Now I'm going to add these two terms together. Again, 2d and negative 2d, they cancel out, so I get a plus Tn. And if I continue with all of them, I get again a plus Tn, which is the last term here. Now there are n terms here, so the sum here becomes n times a plus Tn, because there are n terms which are a plus Tn. This means that if I divide both sides by 2, I get Sn is n times a plus Tn over 2. This is one version of the formula. The other version, which is based on the first term and the number of terms, I can write Sn is equal to n times a plus. Remember that in an arithmetic sequence, we can write the last term as a plus n minus 1 times d divided by 2. This one is t sub n. Now if you add a and a, we get n times 2a plus n minus 1 d over 2. Or I can write this one as n is n over 2, 2a plus n minus 1 times d. This is another version of the arithmetic sequence. So if we know the first and the last term, if we want to find the sum, we use this formula. If we know the first term, the number of terms, and the common difference, we use this formula. The next example says determine the sum of the first 10 terms of the following arithmetic series. The first term is 2. The common difference is 4, so the next term is 6, and so forth. And we know the 10th term is 38. Since we know the number of terms is 10, the last term is 38, and the first term is 2, we are going to use the first version of the formula. So I'm going to say S10 is n times a plus tn over 2. N here is 10, a is 2, last term is 38 divided by 2. 38 plus 2 is 40. 40 times 10 is 400 divided by 2 is going to give me 200. The next example says find the sum of the first 10 terms if the first term is -4 and the common difference is -3. This time, since I know n is 10, a is -4, and d is -3, I don't know what is the last term, so I cannot use this first version of the formula, so I'm going to use the second version, which is Sn is n over 2 times 2a plus n minus 1 times d. Now n is 10, so I get 10 over 2. 2 times a, which is -8, 2 times -4 is -8, plus n minus 1, which is 10 minus 1, times d, which is -3. 10 over 2 is 5. 10 minus 1 is 9. 9 times -3 is -27, so I get -8 minus 27, which is 5 times -8 minus 27 is -35. Now 5 times -35 is going to give me -175. The next example, we have to find the sum of this arithmetic sequence. The sequence is -2, -8, -4, and so forth. So we have to add all these, and we have to find S15. For this case, we know that A is -12, N is 15, and D is any term if we subtract the previous term. -8 minus -12 is -8 plus 12, which is 4. Since I have these three pieces of information, I can use the second version of the formula, which says that S15 is n over 2, which is 15 over 2, times a plus, a is -12, times 2, 2a, plus n minus 1, n is 15, minus 1, times d, d is 4. Now, this is 15 over 2, -12 times 2 is -24, 15 minus 1 is 14. Now 14 times 4 is going to give me 56. This is 15 over 2 times 56 minus 24 is going to give me 32. 32 over 2 is 16, so 16 times 15 which is going to give me 240. The next example, we have to find S20 for negative 11m minus 2m plus 7m plus some terms up to term 20. So here I know that A is negative 11m, N is 20, and D is negative 2m minus 11m, which is negative 2m plus 11, which is going to be 9m. So again, I'm going to use the formula which says that S20 is n over 2, which is 20 over 2, times the first term times 2. The first term is negative 11m plus n minus 1, n is 20 minus 1 times d, which is 9m. 20 over 2 gives me 10. 2 times negative 11 gives me negative 22m. 20 minus 1 gives me 19. 19 times m gives me 171m. Now I have negative 22m plus 171m, which gives me 149m. So I'm going to have 100 times 149m, which is 1490m. The next example, we are supposed to find the sum of the arithmetic series 3 plus 8 plus 13 up to 58. Looking at this one, we know that the first term is going to be 3, so A is 3. D is 8 minus 3, which is 5. And the last term, Tn, is 58. But we don't know how many terms we have. But we know the formula for Tn is the first term, A plus n minus 1 times D, because this is arithmetic. But we know A is 3, n minus 1 times D, D is 5. Now we are going to solve this one. I'm going to move 3 to the left. I get n minus 1 times 5 is equal to 58 minus 3 is 55. Divide by 5. I get n minus 1 is 55 divided by 5 is 11. So from here, n is 12. This means that this has 12 terms here. Now I'm going to use the formula Sn is n over 2 times 2a plus n minus 1 times d. Now we know that n is 12, so S12 is 12 divided by 2. 2 times a we know is 3, plus n minus 1, which is 12 minus 1 times d. D we know is 5. This becomes 12 over 2 is 6 times 2 times 3 is 6 plus 12 minus 1 is 11 times 5 is 55. Now 55 plus 6 gives me 61. And 61 times 6 gives me 366. The next problem is a word problem which says Veranda is offered a job with Tim Hortons that will last 20 hours. The first option pays $4.75 for the first hour, $5 for the second hour. So if I write the total, she gets $4.75 for the first hour plus $5 for the second hour plus $5.25 for the next hour, and so on until the last one, which is going to be 20 hours, meaning that you're dealing with 20 terms here. So this is really 20. Now if you look at this one, this is going to be an arithmetic sequence, and the first term, A, is 475. D is 5 minus 475, which is 25 cents. And the number of terms is 20 because she's going to work 20 hours. So we have to find the sum here and compare it with the next option, which is $7 an hour. So this one, since we are dealing with the arithmetic series, we have to use the formula, which is Sn is n over 2 times a plus n minus 1 times d. N is 20, 2 times a, which is 475, plus d is 0.25 times n minus 1, which is 20 minus 1. If you use your calculator and you find this one, this is going to be 142.5. The next option is that if she gets $7 an hour, in this case she gets 20 times 7, which is $140. And if you compare these, it is obvious that the first option is better because it pays $2.50 more than the second option.